Hello and welcome to the Extended Greg YouTube channel. I'm Greg and today we're going to be doing a bit of a show and tell. So I'm going to be showing a script that I've been working on, which is a music visualization script. And it's a great way to add some visual interest to music as you're just kind of jamming along. So I've been building this from scratch using Python. But before we get into it, be sure to smash that like button and subscribe if you haven't subscribed, because we're about to get extended. Let's get right into it. Okay, so pretty much I have a couple of scripts here. So again, this is what I do with my free time. Take it as you will. So pretty much I'm going to go through the launch script really quick. This kind of sets us up for exactly what we're going to be going through. I'm not going to go through everything in detail, and I don't know that I'm going to release this code just because it's kind of sloppy, but it's just kind of an idea of stuff that you can do using AI to actually help write programming. And in some ways it's easier, in some ways it's not. It definitely took a lot of debugging and a lot of iterations, as you'll see, to actually get there. So it's not the neatest stuff. This particular script I wrote by hand, but it was based on things that were kind of researched and evaluated as it went along, both with AI and otherwise. So first thing I have in this script is I have it so it installs all of the needed pretty much resources for the machine. What I'm actually running this on is a Proxmox instance that we built in a previous stream. And I just created an Ubuntu server on there, installed it, and gave it about 16 cores of CPU, 32 gigs of RAM, and of course some secret sauce, which is I actually put in a NVIDIA graphics card to do a little bit of hardware acceleration. Now, there's still a lot of optimization that I need to do and everything else like that, but I'm passing this through just to be able to leverage what I can right now, and I'm adapting code that I'm using the CPU to do to be able to multi-thread it in the GPU. So, back to the script. So pretty much I'm installing, in order to be able to make that work, is I'm getting everything installed as far as drivers are concerned for CUDA and for the actual NVIDIA driver themselves, so that way the hardware is recognized fully to be able to leverage it within the script. So you see that installing here, it's installing the necessary drivers, it's installing CUDA and all of that stuff, so that way that installs appropriately, and then installing CUDA toolkit and all of that, and then registering those paths, etc. Coming down here, I also install Python 3. That's just what I happen to write this in, just because it has a lot of capability for this type of thing. And continuing down, I actually created a Python virtual environment, which is actually the recommended best practice for Python these days. Instead of actually running it as root or running it as a user, just create a virtual environment. That way it has like root usage within its own environment, but it's still contained within its limited scope. So I create the Python 3 virtual environment, then do source to activate it, and then pretty much from there, install all of the pip packages that I'm going to need in order to run this. So some of those are Demux, librosa, numpy, in order to get some randomization in there, which I think makes the visualizations a lot better. Pillow, noise, modern GL, which is driving a lot of the graphics. MoviePy, which is what's being used to actually assemble the output. So pretty much you input an MP3 and it will output an MP4 with the visualization. And then AV to also help with some of the visualizations as well. Now, to actually run all of this, I'm using XVFB run. And XVFB is pretty much a tool that allows you to simulate a virtual frame buffer. And in lieu of actually installing the full desktop operating system, everything else like that, which also could do the same thing without having to use XVFB, I'm just choosing to use this because it gives a little bit more flexibility, since I'm really running this headless. So it is running in a VM, there's no directly attached monitor or anything else like that. I'm programming through SSH and SFTP and then running it from there. So just want things to kind of move along. That definitely helps out a lot with that. We'll probably be using that a lot more in the future. So going on from there, I go through and I actually check, pass some arguments, things like that. So I have some speed ups that I could do for development purposes, and I actually pass that through to the main script that runs. But first thing I do is I run, if I'm running it from scratch, and we can actually do that, I'll kind of talk through it as we go. But I'm going to use Demux, which is an AI extractor to extract the stems of a song. So it'll extract like vocals, the bass, various instruments, things like that. In this case, I'm only just doing 4 levels just to keep everything kind of simple. So snare being one of them. But that allows me to create more reactive elements of the actual visuals. And in order to actually have something to react, I'm using an object that I just created using Blender. In this case, I just created a simple cube. It doesn't actually care what it is, but I just made a simple cube, which is the default shape that actually shows up when you first run Blender, just because I want something there, but I could potentially put in any kind of a complex shape that I want, and it will put some additional visual elements on there, play with color, and also do something special, which I'll show you in a second. And then we actually run the script itself. So in this case, I'm doing xvfb, and then running the actual Python script in the Python virtual environment. And passing along all of those command line arguments to be able to do some additional speed up options if I'm running it multiple times for iterations, for example. So pretty much from there, I'll go through the script really quick. Which I say that, but it's like 500 lines long, and you'll see why I'm not posting this, because it's kind of bloated. But pretty much it follows your normal syntax for what a Python script is composed of. So I'm going to import a lot of libraries, many of which we installed through pip, some of them are default, things like that, to try and introduce some entropy into it. I did a custom compiled version of FFmpeg, in order to get the hardware acceleration for NVENC, to be able to do the final encoding through FFmpeg, just for that additional speed enhancement. And then after that, I'm importing MoviePy. If you ever get an error where it says you're trying to do hardware acceleration, you're using MoviePy, and it says NVENC isn't found, when you actually install MoviePy, it will install a pip version of FFmpeg, and that has no hardware acceleration by default. So in order to get around that, you do have to declare this environmental variable, or at least put it in a script beforehand, in order to get it to detect that as the actual binary it's going to use, the FFmpeg binary it's going to use. And then I use 2 elements from here. So I do video for video clip, and then audio file clip, which is our existing file, and the video clip is what we're going to be making on the fly. So as we go down here, I have some configuration options, things like that, so I could choose where everything is actually located. I did allocate a separate storage volume just because, depending on the length of things that I'm actually doing, it could get pretty expensive and I don't want to crash the VM. And I choose my resolution, frame rate, everything else like that. And I've even gone through so many iterations, I don't know if you can even see this, but it's version 18. Version 18 of the software itself. So I've done complete start overs about 18 times and numerous incremental revisions to kind of get where I'm happy now. So I had things like pulsate and things like that, but it turned into it gave me headaches, like legitimately gave me headaches. So I was like, I'm just going to turn that off, but didn't want to disable it entirely. So things like that, being able to set, since it is a 3D environment that we're rendering out, because it is using that 3D object to be able to do it, have to define a field of view, which is I made variable. But in this case, since it's a cube, I kind of want it to do something. I don't want it to just sit there, and obviously I don't want to look at it straight on, or it's just going to look like a flat plane in front of me, like a mini screen. which is just going to look really weird. So what I have it doing is I have it rotating on all 3 axes, but in order to kind of make it tumble around, I have it so it's following a sine wave, and I've defined 3 different periods for that sine wave. So that way it just goes around. It's not going in like a consistent oscillation. It's kind of tumbling end over end as it's going, and it follows the lighting, and everything else like that follows as well, which is really nice. And then I have the audio actually nudging it along as it's going through, just to add a little bit of influence. It doesn't really do that much. I have it turned down quite a bit here, but at the end of the day, it is something that, anything to try and make it dynamic. So it just kind of has that presence to it. So it doesn't feel as, I would say, static. I want it to feel more organic, kind of like the music that is there. And then I have, of course, the color control, which is, of course, also based on the music itself as well. So pretty much I go through here, evolution speed, the amount in degrees that the hue is going to shift around, and you'll definitely see that. And then things like how long, when there's total silence, how many seconds, before the colors actually just shift on their own. Because if it's a quiet part, things like that, I just want it to kind of keep moving, keep some kind of dynamic visual element going. I don't expect there to be actual quiet parts during the visualizations, but it is something where I kind of just want to make sure that there's a condition, there's a baseline in there. And then the bass, breath, straight, things like these are just coefficients for how it's actually reacting. And then down here, like the noise speed and the noise scale. So what I did is I actually have a fluid pattern on the surface of the cube, and it's kind of swirling around and doing its own thing based on the entropy that we actually introduced through NumPy. And this kind of defines how random it is, how coarse the particular detail is on there. And then just as a little bit of icing on the cake, because it's just a cube spinning on a black screen otherwise, I actually put comets. So they originate from the center of the screen and go outward to the side like you're flying through, like it's a cube flying through space. And the originating kind of idea behind this was, I was thinking, like, what does the Borg listen to? How do they, when they're going from place to place, like I think I'm driving in my car, I'm listening to music. So how do the Borg rock out, in this case? And like, it's kind of a weird abstract kind of concept, but how they have the cube. So, and it's not always going to be a cube, but I thought that was funny. But so I have the comets here for the stars kind of flying by. So you'll see that, but those are also acoustically reactive. So it scales based on the intensity of the music coming in, specifically the bass lines. That way, you kind of have that growth. So there's fireworks going off really on the screen as it's going through. And this kind of defines what all of those parameters are that make up that. And I'm still tuning them a little bit, so you'll actually see it's not really like overwhelming at this point. I probably could even go higher values with it. But then we define the starting palettes, things like that. And then we get into the actual graphics code. And this is not Python. This is actually compiled code that runs in the GPU. And there's quite a bit of it, things like that. I do have values that I set statically that I, and like this is showing the sign that is actually rotating around the boxes and things like that. So it's doing shaders, things like that. This is a nice block of text that AI was amazing for generating. Because again, this is not my strongest area. I do have a general idea of what it's doing. But again, if I was to write this from scratch, it would just be a little overwhelming to try and actually get something that would compile in runtime and actually run. So it definitely helped in that regard. And here we go through, we see the color palettes get applied, things like that. So we have dark versus light. So there's actually multiple layers, things like that. And you'll actually see that. I actually think some of the color combinations look like the surface of Jupiter, or the gas that you see if you were looking at Jupiter through a telescope, which I think is really cool. And then coming down here, the background is just the comets and things like that. So I have been trying to offload this into the actual GPU itself to reduce the amount of interaction the CPU has to play in all of this. So, you know, the background, everything else, some feedback. So what this is actually doing is it's applying some trails. So I wanted to think about it like comets, not stars. So there would be trails following behind them as they're traveling through space, just so you get a little bit more visual elements. And I also wanted to add color and things like that to it as well. So I have some reactivity related to that in regards to the color choices and when they spawn. And then some basic conversion, things like that as I go through. Some of this I was able to condense, but some of it required modification, and I can't easily do the modifications when it's condensed like this. So you see I've broken it out here. And then we actually head into the audio visualizer itself. And pretty much it's going to initialize it. It's going to do a whole bunch of stuff. It's going to kind of define what those parameters are. I'm going to gloss over this really quick. And it's going to set some static values, initialize all the shaders, get everything kind of initiated. And then as we go down, it's going to set the audio impact, you know, for what it's actually controlling, setting palettes, things like that, updating the particles, and then making the actual frames themselves. So we'll go through, it gets called pretty much for every single frame. It's going to build it one frame at a time to do it. It takes a long time, a lot longer than like a video game, things like that, just because it's not based on a particular engine, and this is not necessarily the most efficient way to go about it, but I would say it's the most accessible just because it is using the plain text. I don't have to compile anything in addition to, you know, anything special in terms of loading the GPU. So this goes through, it sets brightness, things like that, goes through spawning the stuff in the background, which are the particles, things like that. Buffers, things like that for how it's actually going to handle all of that. Again, AI was very helpful in that, and it's Google Gemini. I don't know if I said that earlier, but that's what I happen to use. I know OpenAI, ChatGPT will do this as well, but you know, at the end of the day, that's just what I chose to use in this particular case. And then dealing with rotation, other things like that. I do have the way to actually rotate the entire scene to be able to do that. But again, kind of disorienting, you know, even if it shakes, you know, it's just a little too much because I want to be able to put this on like a big screen TV, something like that, just as like ambient, you know, thing for a party or whatever else. And then down here, it actually is starting to apply it and run it, or I should say update the variables associated with it. It's running. And then here's where the bread and butter comes in, where it's actually rendering out the video. So it's going to create a temp MP4. So I have that stored in a temp directory, and it's going to generate all of those frames. So this is going to define, based on the duration of the audio, how many frames would actually fit in there. So based on that, it's going to render out that many frames. So you see it's just a for loop. So it's just going to go through and range and pretty much generate one frame for each frame, right? Seems pretty straightforward. And it also has a status bar using the TQDM, which is very nice because then you can at least see your process, because some of the render times on this are very, very long. And we're only I'll show you a 30-second clip that will actually render out in real time, but it is something where it's definitely a little bit tough. And then, you know, it's something you realize why I wanted to run it headless and things like that. And then I wanted to fade out at the beginning, fade out at the end, you know, just to give it a nice clean transition as it goes. So I do that through FFmpeg. So once it's all assembled, I'm going to take it and pretty much apply the fade to it. I'm going to do the final transcoding, so I'm going to use HEVC and NVENC in order to create the final output file so it's not that big. As it was creating it up here, right, it was just saving it pretty much to an uncompressed H.264, right? So the quality was 0, which is the highest quality that you can go. It is actually lossless, but the compression is minimal. So I saved that, but it at least gets it into a format where I can kind of put it somewhere without having the processing overhead at that time. And then I just follow back up at the back end, add the audio to it, and the original audio, not the component audio, and encode everything down to the final state that I want for output. And I have a little thing with actually going through and tracking that particular progress as well, and then it's finally done. So, and then this just launches it here if you run it, but it's also a class on its own, so I could potentially include it down the line in other scripts to be able to use it that way. So let's go ahead and actually take a look at this. I should have cleared that beforehand, but what I'm doing is I'm actually running this in screen. And the reason I'm running it in screen is because of the duration of the actual processing. If I do like a 1 hour music file, where I create a mix and then actually go through and want to have it, it takes 10 hours to actually process it currently, which is very inefficient. And that's part of the reason why I don't want to post it, is it's still a work in progress in a lot of ways. But I create a screen, I name it, I called it virtualizer in this case, then I just make the path to my launch script, and then in this case I have two arguments set. So I have test, which will just do 30 seconds of whatever I put in there, and then skip, which just skips it. We'll remove skip just so you see it demux as well. It doesn't take that long. And I just have the -S because I want to see it on the screen, but if my terminal closes for some reason, I want it to continue processing. So if my computer restarts for an update, for example, that I'm able to come back to it really easily. So I'm going to go ahead and run it, and we see it checks every time, regardless of what it is, for if it has the current packages installed, make sure the GPU is connected. It's going to install everything. It's going to check GLX is working, and then it's actually going to separate out the individual tracks. And I do notice a critical thing here. Normally it would just show on one line, but in this particular case, it is too small, so that's why you see it kind of scrolling down. This is what it's actually supposed to look like when it's rendering out. And we see here the number of seconds that have elapsed, the number of minutes still remaining, and if I scooch out of the way here, we see pretty much the number of frames per second that it's actually processing, or iterations per second. So we're just going to let that keep going. And pretty much, I just interact with this using FileZilla in this particular case. So in this case, this is what I've given it. I've given it an audio file, and then I've given it the cube.object, and it will create this final output file. It's going to overwrite this one in particular, but right now we can actually watch it grow and how massive it actually gets, because it's about 8 megabytes a frame. So it grows in size quite substantially very quickly as it is. And we can see the frame counter chugging along here. So it's about 1,800 frames total for the 30-second clip that we're processing out. And, I've gone through, I've saved a couple of choice ones just that I liked, which I have a version 17 one, which is before I started offloading to the GPU, but as I go through it, I don't necessarily want ones that I know aren't what I want. Because when I first started this, it was something where it was just total garbage on the screen, and it was terrible. Like, I tried to have logos and everything else like that over top of it, and it was just freaking the whole thing out, just mainly because I think I had the wrong aspect ratio and things like that for the graphics. But at the end of the day, I just decided I'll keep it simple. I'm just going to do the baseline, for using the objects, everything else like that. I was going to do 2D, I would say, generation of the noise and things like that, but it just looked too flat. So I converted over to 3D as part of it. So it was like a natural process in terms of, as I started to see results, I started taking bigger and bigger steps to be able to say, you know, this is what I'm looking for, you know, and it slowly started to kind of coalesce around what I was envisioning for the time, to be able to say, you know, I'm happy with what I'm seeing here, and then start to put fine tuning on it. So generally speaking, I'm pretty happy with actually how it's turning out. It's just, you know, something where you get a really good feeling after you've coded something, especially something that is hundreds of lines long, and AI helps a lot with that by not having to do it by hand or having to look up, I would say, very niche type of functions that may not be well documented or may be hard to find examples for in the noise of, you know, the internet. So at the end of the day, I think it's something where it's definitely, it has its use cases, but it also has a lot of problems. Like, numerous times I had to go back through and troubleshoot errors that kept popping up, which were very annoying, you know, to say the least. So things like, you know, syntax errors, or I would say old syntax being the biggest problem. Because even though AI is very powerful, it does take into account, I think, almost too much sometimes. So it will actually look at old syntax. You'll be installing the latest version of a particular package, and MoviePy being a great example in this particular case, because they just had a brand new breaking change in version 2.0. And so it kept trying to give the old syntax, and I had to go and correct it and say, no, this is not it. So we see here it's moved on to stage 2, so it's now applying the fade in and fade out, and it's moving along much faster in terms of actually getting the final encoding prepared, since really right now it's just doing the encoding itself, and it's using hardware to be able to expedite that. So at the end of the day, this should only take a few more seconds here. I'm going to show you what that final file is, and we'll actually listen to it together. In the case of the actual music I'm using, I use Suno to generate AI-based music, which is really very cool. So I could use the topic of my choosing. In this case, I want to do very inspirational and positive music, just because, you know, that's the kind of stuff I like to surround myself with. I think it's something where it's really important to stay positive, you know, generally. And, you know, there's plenty of things all the time that will get you down. So it doesn't hurt to just keep reminding yourself of that. So we see it's been successful. So added some nice checkboxes, things like that, but tells us where our final output file is. So if we go back over to FileZilla, right? We go into our storage, we could see the final output visualization. It's now 14 megabytes, which again is not much at all. I'm going to throw it in a folder really quick and overwrite what I have there. And now we can take a look at what the actual output is. I already have this loaded, but I'm going to start it again, so that way we can watch it together. If I can open up the right thing. All right, so I'm going to mute the music here, and let's listen to it.
I spread my wings above the night, chasing stars that burn so bright.
And if you can see it,
Sky's a canvas painted white.
the comets in the background.
Rush, I'm on the ride, flying high, no end in sight.
And obviously it's going to cut off here, but you can see that the cube is reacting. You see the entropy from the random number generator. Sorry, I don't even know if you could hear me, to be honest with you. I didn't actually check the level, so that may have been really loud. But as we actually just look, I'm going to try and... Whoop, let me go to the actual player. Right, so as we see it, it's kind of zooming along. Right, you see some of the comets peeking out. So I need more comets. Everybody needs more comets, right? Right, and they fade off here. They have a tail, things like that. And this is kind of like the surface of Jupiter that I was talking about, but the cube just keeps spinning, and it can do it for an indefinite period of time. So at the end of the day, I mean, this is just a project that I'm working on. I thought I would share it with you guys. It's, you know, I think you might think it's cool, and maybe it inspires you to kind of do one of your own projects to be able to, you know, make something cool yourself. So thanks for watching the stream today. If you like it, be sure to hit that like button and leave a comment down below. And if you know anybody who would like this kind of content, be sure to share it with them. I would appreciate it, and I hope they would appreciate it too. And if you have any ideas for any kind of future streams, be sure to share them in the comments. I try to read all of them, and it's likely that I'll probably get to them in the future. But if you haven't subscribed, please subscribe. It helps me out a lot with the YouTube algorithm. And then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.